Programming Throwdown, episode 77. Julia, take it away, Patrick.
Welcome, everyone, to episode 77. You know, we have a lot of discussions with people and emailing in who aren't in university anymore or are thinking about what to study. And the question always comes up about, you know, kind of the importance of computer science in the, I don't know, maybe it's not the classical term, but how I always thought about computer science. And that would be relative to just programming or software engineering, which I don't keep up on the kind of subtleties of all the different words. And I know we've probably talked about the differences back and forth several times on the show. But what I mean here is the things you would find in a textbook like data structures and algorithms. Pick your favorite.
Yeah, I mean,
flavor.
It's like, you know, computer science 101, right? You sort a list 10 different ways and you build a tree and et cetera, et cetera.
And the thing I want to point out is that even if you're going to, you know, go to some sort of boot camp, if you're watching online courses, learning how to code a website, I mean, these things are awesome. And actually the mechanics of using an IDE, you know, telling a computer what to do, how programs work, all of that is important. And I'm also a huge proponent of understanding actually architecturally how computers work. For me, that's a big help in the work I do about getting programs to run and to run quickly and debugging when there's problems, especially in languages like C++ or C, where you can have, you know, need to be careful about how you use your memory. But what the classic computer science stuff I want to talk about is that there's a lot of work done in academia and understanding problems and thinking about things like NP complete, P versus NP.
Yep.
What are the problems there? What are all the kinds of things that you know, maybe read blurbs about in your textbook or come across, and you know, kind of file them away in your head for later. And what I ran across this week, an instance of this, and I was thinking about it, that, you know, wow, I had never really used the techniques I'm going to talk about in a minute before, but, you know, having come across them by keeping abreast of the like world of computer science, even though in my day-to-day, we always talk about this, how that tech companies love giving interviews where they ask you about like absurd doubly linked list manipulation. You're like, yeah, I never do that in my real job. And this weird math that you think you need to learn, and in reality, you're never going to use it. And and those are mostly true, but it does come up. So I was working on a problem at work it was really quite difficult, and we were having a discussion with my colleagues. And
what is that? Why colleagues in quotation marks?
I don't know, just because like it sounds like really sophisticated, but I don't know, it sound cool.
My comrades.
Yeah. So the people at work, you know, we were discussing this problem. And we had something that was really not doing well. The code was really slow. Everybody's like, hey, we should do better. So I came up with some way of kind of organizing the stuff to be better. And the question came up, which was sort of like, okay, well, how do we test this code? And how do we know can we do even better? Like, how do we know if it's sort of doing what it's supposed to do, which was helping us out with some stuff? And it really kind of bothered me. And I tried to convince some other people, like, you know, I don't really know what sort of the lower bound is on like how fast this code can run. So I don't know whether or not to keep spending time on it. And to kind of bring this full circle, what ended up happening is one night or whatever, it just sort of like got in my head. Whatever you call like a bee in your bonnet. No, that's not the right thing. Anyways, just like,
I think that's
it just sort of like nagged at my head, and I couldn't stop thinking about like the whole drive home. I normally listen to my audiobook and actually just paused it and like drove in silence, just like thinking in my head.
Oh, I've done that too. Yeah, I've definitely had nights like that.
Okay. So it like really bothered me to like just like distracted at dinner with my family, the whole 9 yards. This happens to me every so often. And finally,
yeah, this happens to me too. Not to joke, but this happens to me too. And my wife she'll say something like, "Are you even listening to me?" And I think to myself, no, that's a really weird way to start a conversation.
Oh, that's not good. So okay, I don't. People call this like. Anyway, I'm not going to get off on this. So this really bothered me, and I finally realized, and that what I needed was, you know, what to search for, like a tool or a method, and there was nothing. So I was like, okay, what problem is this? And you know, sort of rearranged it in my head a couple ways and realized, oh, what I have could be mapped, like almost exactly onto the traveling salesman problem. So, or sort of one of the variants of the traveling salesman problem.
Yeah, that's actually a really good point. Is there's a lot of things like sorting, for example, where it's kind of obvious when you need to sort, but there's this whole class of problems where they get applied in ways you wouldn't really expect, and like Sudoku is literally graph coloring. And that's kind of a contrived example, but yeah, there's tons of real life phenomena that can be explained with, canonical algorithms that you learn in university.
Well, I mean, maybe and maybe not. So like Sudoku as your example, since I'm being a little bit vague here just because it's not really pertinent. But yeah, Sudoku is a good example. So if you sat down and tried to like write a computer program to solve Sudoku as a human would, I don't think, at least in my understanding of the graph coloring problem, that would lend itself to, oh yeah, that's the graph coloring problem. So you might go really far with various techniques, but end up in sort of almost a local minima where you're just sort of like running out of ideas. But realizing, oh, this is the graph coloring problem, or learning what the graph coloring problem is, would open you up to a whole new suite of approaches that are sort of like well established. That everyone's like, oh, right, you just use that technique or this technique.
Exactly. Like you would convert, your problem into the traveling salesman problem or the graph coloring problem. And then there would be some solver on the internet that's just like blazingly fast.
Well, okay. So I didn't find that. That would be awesome. But what I did realize is, okay, this is a traveling salesman problem. Oh, and to cover, just in case you don't know, the traveling salesman problem, which I'll hand wave a little bit. But if you think about all the capitals of countries in the world as an example, and you think about their points in 2D on a map, and there's various different statements of the problem, but for this one, imagine that there is a path from every city, every capital city, to every other capital city, and what you want to do is start in one of the cities and visit every one of the other cities one time before coming back to the city you started at. And what you want is the path that visits all of the city, traverses all of these edges between cities, in the shortest distance possible, or the shortest time possible. And solving this is known to be what is called NP-complete. Very, very hard. There's no like sort of polynomial time solution to this problem that is currently known. And so that
just to illustrate this, right? So let's say you're in New York, and there's Boston pretty close by, right? So you might say, oh, I should go to Boston because it's right there, right? But if you have to go around the whole world, then maybe the best thing to do is to make Boston the last city you visit, or I guess second to last city you visit, and then just go to New York at the end. But if you go to Boston first, then you've already drawn that line. You don't need to draw it twice, right? So you have this conundrum of like, should I go to Boston right now, or should I pick it up at the end on my way back? And the only way you can answer that is to, go to the end of the path and find out if you should go to Boston or not. But to do that, you have to go to the end. So it's sort of like this paradox. And yeah, you end up having to explore every possible option.
If you want if you want to guarantee that you will find the optimal path.
Right.
But it turns out, I didn't actually need the optimal answer. I just wanted to know sort of like how far away I was from it. And so what I found by mapping this onto the traveling salesman problem is that, and actually mentioning this to Jason in the pre-show, he actually like, oh, so you just use simulated annealing. So for me, that was what it was like, initially when I was thinking about this, I was like, oh, maybe I could just sort of try all the combinations. And then I realized, oh, wait, yeah, that's like ridiculously large. There's no way. And then I was like, maybe I'll just try random. And then I realized like, oh, wait, this traveling salesman problem in sort of the same logic Jason had. Oh, yeah, I should try simulated annealing, which for sake of time, maybe we'll cover meta heuristics and searching in another time. But it's just a way of saying, hey, I have a very gigantic search space, and I'm going to try what amounts to randomly searching it, but I'm going to guide the random searches in a way so that I'm more likely to go in things that give me spend more time looking at things that give me better answers.
Yeah.
I mean, that's a non-statistic. Yeah. Jason could probably give us a better statistics answer, but that's the layman's, my layman's definition.
Yeah, I mean, no, I think you hit the nail on the head. I mean, just to like explain it through an example, right? So you start by just doing a random walk where you just start at a city and you just pick at a random city and go there, and just keep doing that until you've done all the cities and then go back to your start, right? And so now you have an answer. It's probably really bad. And then what you do is you randomly pick a city and move it somewhere else in the queue. So if there's a city that you visited third, you just pick it up and then you put it somewhere else. Maybe now you're going to visit it ninth, right? And if that new path is shorter than the old path, then you take it. You say, oh, I did something random and it's good. Take it. And if it's worse than what you had before, then sometimes you take it, sometimes you don't. And it's that sometimes that kind of lets you kind of do some exploration. And then you just keep doing that until you get an answer. And over time, you get less and less likely to take things that are worse until eventually you're just only taking better decisions.
And so by doing this, I was able to find out that, actually the thing I came up with was pretty good. And I had somewhat confidence in that I had applied an appropriate technique. And so that was all of a sort of just an interesting thing that came up this week, but also this description of the importance of, I probably haven't read about simulated annealing in 5 years, maybe since the last time we talked about it on the show since then, but I've never actually implemented it myself. I've never used it. It's not something that's at hand for the kind of work I normally do. But, through this podcast, through, just reading about computer science stuff, through having gone through school, it was something that allowed to pull out that tool out of the toolbox and allowed me to map a problem I had onto a sort of well-studied something. And a couple Google searches later, led me to the, pseudocode that I, wrote up in, a couple hours into, a couple hundred lines of code and had it took kind of a long time to run. Actually, I just let it run overnight, but, had the thing running overnight and cranking away at trying to improve my answer.
Very cool. Yeah, the next step now would be to try to export your problem to TSP and see if some GitHub project has some, I don't know, Gaussian process or something that's going to really blow it away.
Yeah, I saw there were some toolboxes out there that are specifically for solving this. But my data set was actually bigger than most of them sort of had listed. So I'm sure they might work, but I wanted to find one that was give it however much data you want. Because I had kind of a lot.
You need to find one that's written in Julia.
That's next time, when I come back to spending some time on this problem.
Very cool, man.
So I have the first news. And this is Microsoft releases their training for artificial intelligence. We've seen a lot of recent releases of videos and materials for training about machine learning and artificial intelligence. These ones look pretty well produced. To be full disclosure, I haven't actually watched any of them yet, but they seem well done and they're free. I like free. And Microsoft stated that they did this because they feel there's a gap in being able to hire people for doing machine learning roles. Probably also as an advertisement, although I don't know. They I think are in their cloud platform rolling out some stuff for supporting people doing machine learning tasks. So I'm sure it's a multifaceted reason that they're releasing this. But if you're interested and you haven't found something that really clicked with you yet, check it out and see if you can learn machine learning. If you can learn to, okay.
Yeah, I haven't seen the videos either, but I'm subscribed to a bunch of AI newsletters and stuff, and this is very, very popular. And so usually things that are popular just tend to be good. That's kind of how it works. The cream rises to the top or whatever. So I haven't seen the videos, but they come highly recommended. My news is pretty interesting. There's a lot of these video games, some of them cost money, some of them are free, but they all have loot boxes. And so for people who don't know, a loot box is this box where you open it up and you get something random. And it's usually something that doesn't affect the gameplay. It's just cosmetic. So for example, You could get, a suit of armor for your character, or a different suit of armor, let's say. So instead of your character looking black, they look purple. You could get, a new helmet or something. But generally, these items, they're just cosmetic, and that way you don't really have regret. Like, if you open the loot box and it's, a scarf and you wanted a hat, it sucks, but, it's a bummer, but it's like, doesn't affect your game at all. But the thing about it is, people, like anything, they associate social value to it. And so there's value to some of these items. And some of the items are very rare. So I think on Counter-Strike, there's a knife that's like a golden knife. It's just extremely rare, and it sells for, hundreds of real dollars to get one of these knives. And so because there's an economy around it, it is kind of gambling. It's like, you open this box. Oh, and the part I didn't mention, you get some of the boxes, as part of playing the game, but you can't open them without a key, and the key costs money. So, the way it works is you both have to play the game a lot, and you have to spend real money. So even if you had infinite money, you're limited in how much content you can get because you have to play. And even if you play all day, you're limited by money, so on and so forth. But you pay $2, you unlock this box, and maybe it has the $500 knife. Or maybe it has, I don't know, the scarf that's worthless. And so, especially in Europe, they're starting to kind of equate this with gambling. And I don't know, I haven't really formulated a strong opinion here, but I do think it's super interesting. I can definitely see the gambling argument. So yeah, I'd be interested to hear what your take is, Patrick. But yeah, the article basically goes on to explain that in Belgium, they've banned loot boxes. So they've officially called them gambling. And so all these games, if they are operating in Belgium, they need to turn that feature off.
This is tough. I mean, to be fair, I don't think I've ever spent money on a free-to-play game like this. I think I've spent money to buy levels or something, but I've never spent money for like a random chance at something or other. Including I played Hearthstone a little while, the card game, and I never paid to open packets of games. And I don't. That seems a little easier for me to reason about, because in Hearthstone, it's sort of like opening Magic the Gathering cards, right? Like, I go to a store and I pay $3 to get Magic the Gathering cards, some of which are rare and some of which are not. I mean, I don't, but in theory I could. And
I don't think you can sell the cards in Hearthstone unless I'm
maybe
mistaken.
not. But the way it works, like Magic, is going to a physical store and buying Magic the Gathering cards gambling?
I think it is.
Wait.
I'd have to double check.
Okay, I don't.
Actually, hang on.
Okay.
You keep going.
I would assume it's not considered gambling, because I know people normally gambling is restricted, or at least how I think about gambling in the legal sense, is normally restricted to having to be 18. And I don't think you have to be 18 years old to buy Magic the Gathering cards.
Oh, that's true.
But of course, gambling could mean lots of things. And so to me, like Hearthstone, like you said, maybe the difference there is gambling that I can sell it back or that I can get cash from it. Because in Hearthstone, I'm able to play the game better. In theory, I could play the game better and enter a tournament and then make money, because I have better cards. And you need the better cards to be able to enter the tournaments, or else you're just going to get, crushed. And so and I know in the one that's always brought up in Japan, is it called pachinko, I think? There's some sort of machine that they play with ball bearings, and you buy money and you sort of put the ball bearings.
Oh, I've heard about that.
And it is really gambling, except that you only get, these ball bearings, which aren't really worth anything, except then you can go down the street and trade the ball bearings in for, something that it has hard cash equivalents, like a little gold coin, like made of actual gold that has value for the gold in it. And so it's like one step removed, but okay. I mean, if you go to a casino and they give you token, what do they call poker chips? Those are technically not money, but you trade them for money.
So I have the official rule on Magic the Gathering. I'm not saying this is right, but I'm saying this is what is. Apparently, because you're getting something physical, it's okay. And so I think the idea there is, let's say you buy a car and I buy a car, and your car ends up being a classic. Like let's say like you buy the first model Tesla, and I buy just a Honda Civic, and your Tesla ends up being worth a lot of money just because it was the first one, and my Honda Civic doesn't, right? Like it doesn't. That's not gambling, and so. I think the claim is, you're buying these Magic the Gathering cards,
and you're paying for the cost of the card.
Yeah, and even though you don't really know what you're getting, they also don't know what you're getting because they don't know in advance that something's going to be valuable, even though they kind of do.
Yeah, that seems right. It seems like convenient, and if you say that, I mean, in reality, what's the difference between the digital games then? Because sure, the company can artificially just make more or less, but Magic the Gathering could just make more or less of any card, past, present, or future. They could just reprint a card.
Yeah, I agree.
Right? And
I think I don't think it's a sensible argument, but that is the logic.
Yeah, so I mean, I do understand that it does seem an awful lot like gambling, right? Like, oh, I put money in, and sometimes I get big stuff out, and sometimes I get something that's not worth the money I put in. But the not worth the money I put in is applicable for lots of things, like if you bought Magic the Gathering cards and were guaranteed to be able to sell every card, if the total value of the cards you had were always sellable for less than the packet price, you would buy infinitely many, right? Your expected value is higher.
Yep.
So we know that's not true. We know the expected value of an open packet of Magic the Gathering cards is different than the expected value before you open it.
Right, and it's going to be less on average.
Yes, or else you would buy infinitely many, right? You would always take that gamble. Okay.
So it's interesting. I mean, that's the rules. I mean, we'll see. I mean, I'm sure the video game companies are going to lobby as hard as they can. And they probably have a case. My thing is, I think, any type of thing where you buy and there's an element of chance like this should probably be age restricted. I have a feeling like, if you're 12, you probably can't really, grasp this concept, like you probably waste a lot of money. Like I know I wasted a lot of money at the arcades, and, not a lot of money, but these people might be spending hundreds of dollars. And so, I feel like you probably should be a certain age or have parent consent or something.
Well, I will say for certain, regardless of my feelings or the ethics or morality of it, is that it's going to have a huge impact on the profitability of games if this becomes widespread.
Yeah, that's true. Although, to be fair, well, first of all, you're totally right. But second, I think these kind of games rely on these people called whales, who are just like a few people who spend an incredible amount of money. So if they could get it age restricted, I think they would still get 99% of their money, probably. But who knows? So that's a pretty controversial article. We'll have to see what happens. I mean, it's just one country in the EU, so it could be the whole EU bans it. It could be that it gets overturned. We'll find out.
Next article is on the taxonomy of tech debt. And this was posted on the Riot Games engineering blog,
interesting.
Who are famous for making League of Legends, right? Yeah. And talks about actually some of the work behind League of Legends. And, everybody talks about technical debt. And I guess technical debt is one of those things that is unavoidable. If you always work to have no technical debt, then you're probably not going fast enough. You're probably going too slow. But this is an interesting approach with some real world examples. And I won't go through all of it because you should just read the article. But he basically comes up with, some measures that he thinks it's important to measure, like impact, the cost to fix, and then what he calls contagion, like the likeliness that the problem will spread throughout the whole system and, sort of cause disruption. And then also whether the debt is sort of like local to an area or global, whether it's like somebody came in and did something crazy, like just sort of like, what would you call those? Like archetypes, like prototypes. Archetypes. There we go. Thank you. It's late. My brain's not working well. Archetypes of, here's the kind of things that would cause various styles. And he kind of writes about it. So I encourage you to read it. And I thought it was pretty well put. And it's always a struggle to talk about technical debt. And instead of shipping a new feature, taking time to fix something that, is probably not broken, but is either has a risk to make something broken or is causing problems to slow down or hurting, the joy of working in the code, whatever it might be. It's always difficult to stick around. So having more thoughts on how to think about and describe that is always welcome.
Yeah, totally makes sense. Yeah, the worst kind of technical debt that I've been experiencing a lot of lately is where things just fail silently. And that's one thing, over the years, I've gotten more and more loud with failures. Like, if there's an input and it should be between 1 and 10 and it comes in as 11, I just crash the whole binary. And part of it is because, I'm not working on like a rocket ship or something where you can't do that. But, we've been really burned lately where, for example, we had this issue where this library was reading rows of data. And if the data didn't fit, if the data had errors, basically, it just skipped the row, but it didn't warn you or anything. And so we found that only 10% of our data was being read, which, and of course it wasn't a random 10%. So it totally skewed, all of our results. And just, stuff like that is the worst. So, that's
it's especially,
but yeah, this is cool.
It's especially bad, if you're doing something where you're building statistics or measuring something, because you could easily be missing, like you said, 90% of your data, and it wouldn't be immediately obvious you were.
Yep. Yeah, it went on for a long time.
Oh, man.
My article is Ubuntu 18.4 is available. So this is a big deal. So Ubuntu has what's called LTS versions, long-term support versions. And these are basically versions that, have been vetted very carefully. And also if you're a paid, like if you're a corporate, sponsor of Ubuntu, or if you pay into their customer support and all of that, they will support the LTS versions for, years and years and years. So if you're on, 17.10, after maybe 12 months, they're like done. Like if you need help, I'm sure you could pay somebody to help you, but it's going to be much harder. But if you're on 16.4, you can get help for a long time, even years from now, right? And so the LTS versions are pretty rare because of the amount of, customer support and all of that goes with it. Also, a lot of libraries. So if you need proprietary libraries, such as the CUDA library from NVIDIA, NVIDIA is actually pretty good about having it for different versions, but a lot of people just support the LTS version. So if you have some custom driver, you're stuck on 16.04, right? And so 18.04 is the LTS version, which means a lot of people who've been waiting to update can update. And, you go from, I think it's like GCC 5 to 7 or something like that. It's a huge update, right? It's out. It came out today. I haven't updated yet any of the machines in my house or anything, but I'm looking forward to it. I think it looks a lot nicer. A lot of the graphical issues have been fixed. I think they were using LightDM. They switched back to GNOME, so it's going to look pretty different. I'm not sure what the upgrade path is, but if the upgrade path switches it back to GNOME, it's going to look pretty different. But yeah, it's a pretty big announcement. I'm looking forward to getting everyone on there.
Do you run Ubuntu at home?
So I have basically I have two media center PCs, one per television, and they both run Ubuntu. And my desktop dual boots, but I typically just stay in Windows for that. But I do have Ubuntu on the desktop. Nice. What about you? Are you running Ubuntu?
No, I run Windows. I'm a horrible person.
Yeah. You run
I'm just kidding.
Temple OS.
I'm just kidding. No, I run Windows. My wife uses the computer, and so it's good to have Windows on this, which she's used to. And then, I do it for some gaming, and I think Ubuntu has probably come a lot further. And last time I used it, it was way better than the time I had used it before. So I'm sure it works pretty well. I just find myself not using desktops and laptops as often anymore. So
that makes sense.
I just don't have them up very often, and so they're just on Windows because that's what they've always been on.
So, do you have PCs hooked up to your television?
So I have Chromecast hooked up to my TV.
Oh, okay, got it.
And then I have
sorry,
go ahead.
Oh, I was gonna say I like predate Chromecast, so
yeah,
like I just have computers for each TV. But like when they break, I'm absolutely going to Chromecast. But for now,
yeah, Chromecast, like the Fire TVs, like I think these ones work pretty well. Having a media PC does allow you to do some stuff. I just found the hassle of dealing with it wasn't worth the few extra features that I wasn't using very often.
Yep, makes sense.
And then I have a NAS that has the ability to do stuff like have a Plex server on it and stuff. But it runs a custom OS from, I think it's Synology or whatever. Yeah. So it runs some version of Linux under the hood. I don't know which one. But I've not like jailbroken it. I'm sure I probably could just run whatever on it. I just run whatever it came with because I just want it to be stable and, keep itself happy.
Yep.
So boring setup. I'm sorry.
There's no reason to do something crazy.
I should do something cool.
We talked about this before the show, but we talked about our networking setup a few shows ago, and I had this totally jacked up, Netgear router that I just hacked and had all these extra services on, and it basically died. So, and I pretty much voided the warranty by, doing all this crazy stuff. So, I'm just running stock stuff as well. Time for book of the show. My book of the show is Economics, both an X. So I think my last book of the show is Basic Economics by Thomas Sowell. I'm actually still reading that. It's a very long book. It's like 30 chapters. It's also pretty dense, so I have to kind of keep going back and rereading. So I'm kind of, trudging my way through that. But there's a person on my team who is an actual economist, and he recommended this book as another kind of book for getting into economics. This one is actually a comic book style. So if you're into like graphic novels and things like that, you'll like this. I haven't read it yet, so I can't vouch for it directly, but I've been some people who know way more about economics than me said this is the book to get people started, get lay people started. And I'll definitely be reading it once I finish the Thomas Sowell book.
Very nice. Yeah, you've been really into economics recently.
Yeah, I think it's really got a hold of me. I think it's fascinating. I'm not so interested in like the stock market or anything like that, but yeah, the way the engine works is super, super interesting. And I feel like computer scientists should really study economics, like the thinking of it as this like really complex adaptive system, taking it from that perspective, I think is really interesting.
So we've now recommended that everyone go study more CS, that everyone go study AI and machine learning, that they all go learn economics.
We're going to create an army of superhumans.
This is, we're going to just keep going. We're going to have tons of recommendations.
Yeah, if you've done any of these things, let us know. If you do the Microsoft course, we're on Facebook, we're on Twitter. Actually, I think so Facebook definitely has the biggest audience, but I think if I had to pick one place for people to, message us, I think Twitter is probably it. Just
when he says us, he means him.
No. I mean,
show.
Yeah, the Twitter is technically mine, but I never tweet unless it's about the show. So yeah, it's at Neural Nets for Life. You can look it up on our homepage. But if you tweet us and you add us, then it's public. Like if you comment on our Facebook, it's kind of hard to find that. But I've noticed when people tweet at us, they typically, then other people respond to them, and it actually starts kind of a nice thread. Versus when someone comments on our post on Google Plus or Facebook, it just kind of dies. The comment dies.
Oh, I haven't been on Google Plus in a long time. I should go on there.
Yeah, If you've done any of these things, read our economics book or taken the Microsoft course or anything, let us know, man. It'd be great to hear.
My book of the show is Black Prism by Brent Weeks. This is the first book in I think it's supposed to end up being 5 books. I think the 5th book isn't out yet. I'm not exactly sure because I'm only on the first book. And I think there's like a book in between one of the books, maybe a short story or something. But Black Prism is pretty good. I've not read anything by this author before, Brent Weeks. I'm actually not quite done with it. I'm like one chapter away from the end or something. So it's like, everything's kind of wrapping up, or at least no spoilers, I don't know, maybe it will or won't. But I'm like 1 or 2 chapters from the end, and I'm really enjoying it. It's a fantasy book, and they have magic, but the magic is sort of based on light, hence the name Prism. And so people use light, and it's not super scientific, whatever, but it's a sort of an interesting read and an interesting play where people are able to sort of use certain wavelengths of light to do things. And so like you might be able to use red light to do, magic using red light, and I might be able to use green light to do, magic with green light. And it just talks about various things along those lines for the magic system. And I find it pretty interesting, and the book's been a good read so far. Cool. Some intrigue building. You can definitely tell it's going to be part of a series. So, and I think the author actually has several other series in various states as well. But this one is part of the Lightbringer saga. So I'm enjoying it.
Nice.
I'm enjoying it. I'm pretty far through it. And I recently started picking up a little bit of podcasts too. But I don't know. As much as we make a podcast, and you should keep listening to our podcast, something about like listening to a book, I don't know, I get really into it, and it's like really long form.
I'm actually doing both. I'm listening to there's this podcaster, Stefan Molyneux, and he talks about he's just like a really, really hardcore libertarian, like way more libertarian than I've ever seen. Like he's like, there shouldn't even be public schools, and just like way out there. And I just find it fascinating. I mean, I can't say I really agree with everything. But yeah, I've been following his podcast and a couple others.
So yeah, I mean, I enjoy audiobooks. I use Audible, have for like a long time now. I have so many books because I have a pretty long commute. Nice. But if you're interested in trying out Audible and you want to help the show, you can go to audibletrial.com/programming throwdown. And they'll give you a 1-month trial, which is good for a free book. It's pretty much any book in their whole catalog, which they have just like tons of stuff. And so you could check out. Jason said economics is a comic book, so I won't even bother looking and seeing if they have that. But you could check out the Black Prism, or look back through our show notes and see many books we've recommended, or whatever your favorite might be, and enjoy that. So that's like one.
Yeah, do us a favor. Yeah. If you do want a book that we have on the show, and you have, let's say, the Audible credits, if you click on the link and then you buy the book, even using your Audible credits, that still helps the show, by the way.
I did not know that.
So yeah, all our Audible listeners can still sort of help the show and get the book they want. So it's kind of free for you. It's like no effort by clicking on our link and then choosing the Audible choice.
Oh, I did not know that. It's a good tip. Cool.
Yeah. You could also, if you are already an Audible customer or want to help out the show another way, you can subscribe on Patreon. Just to give you an update on the Patreon, so Patrick has made all of the Christmas prizes. I know we're woefully late. But I still have all the addresses. Also, by the way, we only have addresses for about half of the Patreon subscribers. So if you don't have your address on Patreon, at this point, just email me. So if you send me an email, just give me your name and your address, your social security number, your credit card.
No.
Yeah, no, just give me your name and your address, and I will, connect the dots, and I will make sure that you get a Christmas present. But yeah, I mean, at the moment, we actually have extras because so many people don't have their address.
You should post something on the Patreon feed too, just as a.
I did already. Yeah. But if you didn't see that, and or maybe you don't want your address on Patreon, it's totally fine. You can just send me an email, and we'll make sure to add you.
Yeah, and it's also fine if you are like, I don't want to give these guys my address, and I don't want a prize. That's fine too.
Oh yeah, of course.
If you want to be anonymous and mysterious.
If you don't want this, I'm looking at them right now. A whole stack of them. They're pretty cool. I'm excited. Actually, my son loves it. I gave him one of those.
Wait, I don't know that those are childproof. I think they have sharp corners, don't they?
They are now. Actually, I think he broke one.
Oh, don't let him eat it. I would feel terrible if your son got...
No, he's 5 years old. He's not going to eat it. Oh, man.
Time for tool of the show.
Tool of the show is forceps to get things out of your child's mouth after they've eaten. My tool of the show is Brutal Doom. Brutal. This is really, really cool. So here's how it works. First, you have to buy Doom.
Step 1.
You can either get Doom 1 or Doom 2. Actually, sorry, you have to buy Doom 2. Then you get this Brutal Doom. So what this does, it's kind of
brutal,
built on top of layers and layers. So there's a lot going on here, but I'll try and break it down as simple as possible. Basically, so Doom, the source code for Doom was released by id Software a long time ago, maybe like 15 years ago or something, right? And maybe not that long ago, but a long time ago. And someone, just went through and, took the parts of the source code that load all of the data, and they, brought that over, but then they rewrote the whole game engine. And so you can use the mouse to look around. It's just faster. There's no limit to the number of enemies that could be on the screen at one time. All these, old limitations are gone. And it looks way better, et cetera, et cetera. So it plays just like a modern FPS now, right? And so then there's this thing called Brutal Doom, which is where somebody has modified the engine to just make the game basically more intense. And so the way it works is it kind of sits on top of the existing game content, and it kind of patches it, and then also patches the engine. So, for example, all the weapons are different. The enemies are different. Like their AI is totally different. They look different. They don't look different, but they have different attacks. For example, like the imps will actually jump at you. The demons will jump. So they act different, and they have different animations and stuff. And it's also just extremely brutal and very satisfying. It's kind of, I don't want to say it's it is kind of messed up. It's kind of messed up. Like if you shoot one of the enemies, sometimes they lose a limb and then they start kind of crying, and you have to kind of put them out of misery. It's kind of weird. Yeah, it's kind of messed up, but it's super, super intense. Everything is really fast. It's by far the fastest FPS I've ever played. You just move so fast. You move faster than the rockets and stuff, right? That's always kind of been true in Doom, but this really takes it to the next level. You can play co-op. It supports playing over the internet, so you don't have to play over an IPX wire or anything anymore. And it is just super, super fun and satisfying. And if you like Doom, you'll just absolutely love this. The other part of this is this guy actually went ahead and built his own campaign, so a whole new set of levels, and he calls it the Hell on Earth pack. And it's something like 30 or 40 levels. They're extremely, extremely well done. Just super high quality, some really interesting stuff. He kind of keeps you on the edge of your seat. He's got friendly AI. So there's a part where you fight a huge battle, you and a bunch of AI Marines fighting a bunch of enemies. There's a part where you lay siege to a castle with catapults. It's insane. And to top it off, he's actually releasing another whole new set of 30 levels, a completely new campaign. And they're going through the beta testing now. You can get the campaign if you subscribe to him on Patreon, or you can just wait. I think it's going to come out in a few months. But I played this. I thought, the last part of this is, you don't have to play these new campaigns. You can actually play the original Doom or Doom 2 just with, the modified, engine. And it will, the designers have made sure that the games are beatable and all of that. Super, super fun. I highly, highly recommend it. It's a blast. It's brutal.
Well, prepare to groan. My tool of the show is YouTube. Never asked for it. No, I was telling Jason before the show, and I stand by this. My life would be different in many ways if YouTube didn't exist.
Yeah, I mean, joking aside, YouTube is probably the best tool we've had on the show. I mean, if we just look at it objectively.
Yeah, I mean, I think I take it for granted, and we've been on 7 years now, so there are probably people listening to the show now who are like, yeah, man, YouTube's like TV. Like, you wouldn't be like, TV is the best tool. But thinking about, I went skiing a couple months ago, and I'd never taken lessons. My dad sort of taught me how to do it. I'm really horrible at it. And I was like, I kind of want to be better, but lessons are expensive. I'm going to look on YouTube. Sure enough, went on YouTube. There's super professional videos and instructions about how to ski and do better at skiing. And sure, it's probably not anything close to paying good money for a real instructor, but it definitely helped me. And I know I skied better because of it. And it didn't cost me anything other than time that I probably would have spent doing something else anyways. And just the amount of learning you can do on YouTube and using it for repairs around your house or fixing problems and things that just would never, reading someone talk about skiing just doesn't work. I couldn't have found someone's blog and been like, oh, I see what I'm done wrong. No, video is the way, right? I mean, it's just, it's sort of obvious.
Yeah. Yeah, when I had to learn how to, basically a part of my son's bed kind of broke. And I wanted to fix it and also kind of just reinforce the bed because it's cheap IKEA bed. And I went on YouTube and I looked up, how do I use a jigsaw? How do I use a table saw? And I mean, just seeing someone do it is so important because especially you can watch 10 people do it or 100 people do it. And each time you'll learn something a little different.
Yeah. And it is true that sometimes you can get bad advice. But
sure.
I think you said earlier, kind of cream rises to the top. I think often, especially in the how-to stuff, the people who kind of are doing stuff that's very dangerous often get flagged for doing stuff that's very dangerous. So.
Yeah, I mean, I looked up how to use a jigsaw, and the video had millions of views, and it was just very professionally curated. And yeah, I mean, in theory, and if someone could trick you, for one, they probably have a lot of thumbs downs. That has a big impact on the search results and all that. So yeah, I wouldn't worry too much about it.
But specifically the thing, and this relates to kind of what we were talking about before, things that you don't use often, but when you do, wow, it's nice. Is I've been watching this channel 3 Blue 1 Brown, and this guy goes into all sorts of discussion about math, and not what is Khan Academy. It's very practical math and how to learn. That's great too. But that's very different. This is for math that you would never, or I personally would never have attempted before, the Riemann zeta function. And he'll describe in it makes me feel like a superhero. I understand the Riemann zeta function and what the zeros and how it relates to prime. I mean, I don't, but I watched it and he convinced me that it's totally obvious and intuitive how these things relate to the primes and why. And, just a great video, great channel. I don't remember how I came across it. I think maybe I had Numberphile on a while ago, I think last time. And this, I think, was referred to it. And I might have even talked about it last month if I did. Oh, well, because it's really good. The videos are a little long, but, definitely worth it. The explanations he gives and the understanding of math. And I think it's one of those things where, although I'll never probably have use for the Riemann zeta function, the way he breaks down and thinks, and he does this talking about mapping from one problem onto another for looking for solutions, which is very common in mathematical proofs. And that technique, right, it just helps get you thinking about those kinds of things, enormously valuable. So YouTube, and for a specific channel recommendation, because why not 2 for 1, 3 Blue 1 Brown.
Very cool. Yeah, I mean, a similar one that I follow is called TED Ed, where it's I don't know how it's affiliated with TED, but it's just high quality.
It's a guy named
TED. No, it's high quality cartoon style animations, but explaining some concept. They had one the other day that was why you can't divide by 0, and but I mean the thing is, I mean obviously you can't. They go into why you can't do that and why if you could then 1 would equal 2 or whatever. But then they explain how you can't even really fudge around it. Like you can't say 1 over 0 is infinity. Like you can't really even write a rule to handle that, because any rule you write ends up contradicting itself. And it's just super interesting. Very cool.
Time for talking about Julia.
Julia. My wife actually saw, Julia on my computer, and she's like, "Who's that?"
I would name some famous actress, but I'm drawing a blank. Julia. There's some Julia.
Julia Roberts?
Maybe. I was thinking Julia Childs. She's a chef, right?
Oh, yeah, right. Yeah.
Yes, we know pop culture.
Yeah, exactly. First cultural reference, 7 years in. So, to talk about Julia, you really have to talk about scientific programming, like at a high level, because Julia is in this class of languages, that contains, MATLAB and R and things like that, NumPy. And the core idea behind all of these has been that, you have a slow interpreter, like the MATLAB interpreter is just extremely slow, but then each individual instruction is super fast for what you're doing. So to illustrate an example, let's say you have 2 vectors and they're of length 1,000,000 each, and you want to add them together. Well, if you write a for loop in MATLAB, for 1 to 1,000,000, C of I is A of I plus B of I, that's going to take a long time. And I mean like maybe a minute, right? But if you do C equals A plus B, if it's just one line in the interpreter, that line can be very complicated and time consuming, and MATLAB will do that just extremely fast, like not even a millisecond, like a fraction of a millisecond, right? And so the way that these things work is, under the hood, for each instruction maps to a bunch of really complicated but extremely fast logic. So there's BLAS libraries, which we've talked about in the past. BLAS means Basic Linear Algebra System. So, for example, there's sort of an API that you can adhere to be a BLAS library, and it says things like, add 2 vectors, add 2 matrices, multiply matrices, so on and so forth. And if you implement all of these functions, then you support, BLAS level 1 or whatever, right? And so, the best, these BLAS libraries, they have trade-offs, and MATLAB typically has all of them, and it knows to use the right one at the right time. There's things like FFTW, which stands for Fastest Fourier Transform in the West, which is just, as it says, just a super fast Fourier transform library. Things like OpenMP for multiprocessor support, things like that. And so you don't have to know how any of these things work, or that even any of them are happening, because it's all kind of behind the scenes. But the price you pay there is that each instruction now requires a lot of thinking. MATLAB has to really think about what to do, and so things like for loops are just going to kind of kill your performance.
So
go ahead.
So when you said that the realm of scientific programming or whatever, I mean, this is one of those places where that there's actually still a lot of people using Fortran, sometimes we think like scientific programming, people using SciPy and NumPy, but I mean, there's still a lot of people using languages much older than that.
Yeah, that makes sense.
I mean, I feel you're more in that realm, I guess, than I am. So, I mean, is like of the mindshare, is Julia competing against these old ones or competing against something like Python?
I think Julia is really competing with MATLAB. So at work, there's some people using Julia, not really on my team, but it's a huge company, and there's a whole group of people using Julia, and I notice almost all of them are ex-R or ex-MATLAB people. So yeah, I think. So yeah, to your point, I mean, when you say scientific programming, I mean, of course, like, you can do scientific programming in anything, but typically, like, scientific programming languages are ones that are more high level, make it easy to experiment. And so that's why like most of these languages will have like an IDE built in. So for example, MATLAB has MATLAB. Like you start MATLAB and it pops up this whole developer environment where you can see the status of variables and look at plots and things like that while you're coding. And so for Julia or NumPy or any of these, you'd be using Jupyter, which Jupyter is what is the rebranding of IPython Notebook. And so one of the reasons for that rebranding is Jupyter supports Julia, supports, Torch, which is in Lua, and a bunch of other things.
Nice. Supports,
what's it called? Spark. You can do Spark in Jupyter now.
So what are so for Julia itself, though, what are the features that it really has?
Yeah, it's a good question. So like why does Julia, really stand out, right? So if let's say you're a MATLAB user or an R user, what's really the reason to switch, right? One of the biggest things about Julia is it embraces the sort of asynchronous paradigm, which we talked a lot about back in episode 41, which was probably years ago. But in the Node.js episode, we talked really about this whole async paradigm. And the idea with async is pretty simple. It's just, you call a function, but instead of it doing what it's supposed to do, it just goes off and starts working, and it gives you a future. So let's say you in Julia, and I'm going to kind of be a little hand wavy here just so I don't have to like speak in code. But in Julia, you say async 1 + 1, and it doesn't return that line. If you say a equals async 1 + 1, that's not just a is not going to be 2. A is going to be equal to a future. And then whenever you go to use a, so let's say you now say c equals a plus b. Now c is going to be a future, and this keeps going and going. And eventually you're going to need to know a value. So let's say you print c, or write C to a file or something like that. Now all of a sudden Julia says, whoa, hang on. All of these features, I need to know now what they actually are. And so what it's going to do is it's going to, start blocking on these features. So it's going to say, hey, C, do you know what you are yet? And C says, no, I'm waiting on A. It says, oh, okay, A, have you figured it out yet? No, not yet? Okay, I'm just going to hang out. And then A says, oh, yeah, I figured it out. 1 + 1 is 2. And then C says, oh, now I got my value too. And then now you print C, right? And so, when you're writing code like this, you're just accumulating a lot of these futures. But then, while this interpreter is running and doing this, those futures correspond to, tasks that are running. And they could be their coroutines. So they're running in the same process. Just in a separate, a separate thread, just to be a little more hand wavy. They could be separate threads. They could be separate processes. They could even be on another machine. And that's one thing that really sets Julia apart. In Node.js, you can do, async function and you'll get a feature and, same kind of thing. But, Node.js won't actually ship that function over to another machine. That's a whole different universe, right? Because, you think about the complexity there. Like, for you to ship a function call to another machine, that machine has to have all of the context. If that function uses a library, then that library has to exist on the other machine. Then there's also some things that just can't happen, right? Like if that function tries to read from disk, well, now you're kind of in trouble if you assume that it was going to be on the same machine, right? And so, in Julia, there's ways to say, run this asynchronously, but it has to be on my machine versus I don't care, just run it anywhere. But the cool thing is let's say you have some program where you're, loading some images from disk, you're doing a Fourier transform, and then you're running a convolutional neural net, and then you're adding the two, and you're doing some other stuff, and you're calculating bounding boxes. Like you could just do all of this, and Julia will farm out all of these tasks, and it'll use as many resources and machines as you give it. and as are allowed by the commands you're specifying. And then it's going to try to keep itself busy. And it's got a lot of it's got built-in sort of pool support. So let's say you have 120 images that all need to be processed. You could just say, hey, Julia, process all 120 of these as fast as possible. And it's going to go off and do that. And so there's a lot of complexity there that's hidden from you. Like, for example, let's say you have 10 computers and you tell Julia, process these 120 things as fast as possible. Julia will send the first 10 out, but then let's say the 10th one comes back first and the other 9 are still processing. It's not going to wait for the other 9 to finish. It's going to just send the 11th one to that machine that's done with the 10th one. And so it's kind of keeping track of everything for you and making sure that none of the computers are really waiting if they don't have to wait. So that's, that's the really kind of big ad. And it seems really cool. I mean, if you come from sort of a MATLAB environment where you're loading an image, that happens probably instantly, but then you run a Fourier transform, that might take a while, or you're writing a for loop to loop through all these images and process them. And you go to something like Julia, where, you just have this one line that says, hey, here's 10,000 images, just go. That's really nice, right?
So you compare it to MATLAB, but one of the things about MATLAB is really expensive.
Yeah, that's true.
And I was going
to say, and even if, for things that are free, we've had this issue with Java recently where, Oracle actually ended up winning that lawsuit. And so, Google is going to have to pay Oracle, was it like billions of dollars? It's something crazy. But there are some languages that they're not, or packages or whatever, where they're not, they're free, but then they have sort of like a catch, right? Like that, they have a really restrictive license or whatever.
Yeah, although, I mean, I guess for Java, most people are probably not doing what Google did.
Yeah, I don't know the details on that.
So,
like, if you just use Java, is it okay?
I'm not a lawyer, so I'm...
Yeah, that's true. But let's just say that you don't have that issue in Julia, because Julia is completely MIT licensed, which is, for people who don't know, MIT and BSD are the two licenses where, if you talk to a lawyer, that those are the licenses that will make them smile, right? Like if it doesn't say MIT or BSD, the lawyer is going to have a lot of questions and be really nervous about using that software. So Julia is totally unencumbered.
So I don't know if this is correct. For home use, MATLAB, even just for home use, is $150.
Wow.
For a standard license for 1 year, presumably for a company, it's $860.
Wow, that's wild.
I mean, there's probably more. Like, I think at many companies, they have like sort of network licenses that get checked out and stuff. So maybe it's cheaper. Right. But I mean, that's a lot of money.
Yeah, I mean, it's insane. And the open source community has, caught up. I feel as if MATLAB might not have a sustainable business model.
Yeah. I mean, but MATLAB is really good, to be fair. Like, it's not like some stuff where, this is some arcane package, but if you really need it, you'll pay the money. I mean, MATLAB, I don't know. It's hard to say you get your money's worth when you compare money's worth to free. That's the divide by zero thing, right?
You get good support, probably.
You probably do, but MATLAB is a really good piece of software, and I think we should be willing to pay sometimes. But if you're not going to use it a lot, it's hard to be like, I'm going to pay this money, and I'm not sure if I'm going to use it.
Yep. Yeah. Exactly. And keep in mind, like if you're an enterprise customer, you're invariably going to run into some problem. And you're going to have millions of dollars on the line, and you're going to just pay someone a lot of money to fix that problem. And so, even though, people might say, why is this free? What's the catch? Well, that's the catch, right? The catch is, that I'm sure this company is charging for support and, things like that. With that said, it's not a trap. in the sense that, the software is extremely professionally done, very worth, the effort. But it's a bit of a question mark. Like with MATLAB, I guess you pay the $800, but presumably you get some level of support for free.
The forums.
And you're
I said you can go to the forums. The MATLAB phone.
No, but I mean, I'm assuming if you have a license, there's a phone number or something. I don't know. Maybe I'm not. Maybe I'm making it up. I mean, I know I'm making it up, but maybe I'm wrong.
But I mean, yeah, I guess to point out too, we've talked about this in our MATLAB episode, but for a one-to-one replacement for MATLAB style stuff, I guess you'd probably consider Octave. So Julia isn't going to be a drop-in one-to-one replacement. But for the style of work that is often done in MATLAB, that would be where you could consider Julia.
Yep. Yeah, exactly. In terms of like, one of the hesitations using Julia might be that it doesn't necessarily have so much support in terms of library. Like, for example, let's say you need to load, I don't know, some geospatial data that's in some GIS custom format or something like that. Or you need protocol buffers or I don't know, whatever, right? You might say, well, I'm taking a risk using a language like Julia because it's not going to support something I really need. They do have a Julia Pi library, which lets you run Python code inside of Julia. It is pretty good. It actually, they wrote a bunch of logic there to handle NumPy arrays. So if you create a NumPy array in Python, as part of some process, part of this Julia Pi, process, and then you need to bring that back to Julia, they'll actually just do a pointer assignment. They're not going to actually copy the... Actually, I think they... if you create a NumPy array using the Pi data, or the Julia Pi data object, so there's a little bit of a, some stuff you have to do that's a little bit special. But basically, it's very performant. You can call into Python if you need to, and that shouldn't stop you from trying it out.
So one of the cool things that I found about Julia was that there are only 4 high-level languages that have ever been used to write computer programs that executed at greater than 1 petaflop sort of compute power. And so those are C, C++, Fortran, and Julia. So that was a pretty good accomplishment. Nice. And you were talking about the, support for distributed messaging and working and that kind of stuff. And this is sort of evidence of that isn't every language that you would use in such an environment. And one day, I guess, everybody will have a petaflop under their desk. But that day is not today. And it was interesting that I would have thought the number of languages would have been higher. But at least according to Wikipedia, this is, it's only 4 languages, 4 high-level languages that have ever been used to build programs that have run at that processing power.
So I have to confess something terrible, which is, like, I don't actually know. I don't have an intuition as to how flops relates to like megahertz or gigahertz. So like, can you put it in?
So sure. I wasn't ready for this. Flops is floating point operations per second. So a petaflop is 10 to the 15 floating point operations in 1 second. So that is, if you think about...
that's a million gigaflops, is that right?
Gigaflop is 10 to the 9, million gigaflops, yes.
Yeah, okay. So if you think of a gigahertz computer as doing that many instructions, and if you could assume that you do like a flop in 1 hertz, then this would be a million gigahertz.
I didn't follow that
Something
math.
like that.
But I mean, the idea is that so floating point operations can take longer and often do take longer than integer calculations. So in your computer's ALU, right, you might be able to say, I want to increase this number by 1. And for an integer, that's straightforward. Like there are literal like gates that just execute that, not instantaneously, but within 1 clock cycle and handle the results. But to increase a floating point number by integer value of 1, you can't just sort of directly manipulate some bits, like the amount of logic you need to do for the various
Makes
parts
sense.
of the floating point number mean that it takes a little longer often. So depending on your architecture and the exact computers, and this is why you have things like high performance computer clusters that often, not always, but often run different hardware or might run certain kinds of processors that are different, is because of this ability to focus on floating point operations. So if you're doing something like computational fluid dynamics, where you're, say, modeling how air flows over an airplane wing, and you're trying to understand where there's turbulence being generated. And so you're sort of figuring out how air molecules move around roughly, right? Then you're doing all of this with floating point numbers, and you need to do a lot of them because there are many, many, many things to be evaluated all at one time. And so that's where having these supercomputer clusters measured in petaflops is they're basically running one gigantic distributed computation that is like, this isn't exactly right, but imagine if you were going to actually simulate every air molecule, right? So the simulation wants to advance 1 millisecond, and you need to, for every air molecule in the volume of interest, you need to figure out where that air molecule would go. Would it bounce off of an object? Would it bounce off of another air molecule in this, sort of 1 millisecond interval? And do that for every air molecule, and then you update, and now you have the new state. And now you need to keep doing that. Except when you bump into another air molecule, you sort of have this cascade effect. It's very complicated, right? So that's a sort of contrived example. That's not how they do it. But if you sort of think about that, if you were running a simulation that did that, that would be enormously computationally expensive. And so when you have these things measured in petaflops, the supercomputers, for some things you can let them run really long. But if you're trying to do like weather forecasting, if it takes you 5 days to forecast what the weather's going to be tomorrow, that's actually not useful. Yeah, I mean, I guess it kind of is useful, but it's not useful for forecasting.
No, it makes sense. I guess the thing I'm not sure about is, if Julia is C++ and C under the hood, then does it
Wait, but it's not C++. What do you mean by under the hood?
So in other words, the Julia operations, I mean, obviously the farming to other machines and things like that are written in Julia or maybe written in some high-level language. But under the hood, the thing is doing the computation. It's still calling to some BLAS library or something.
I mean, it's ultimately calling machine code, right? But the program itself, the thing that is doing it's not scripting, but doing the high-level hooking together of all of the pieces is written in Julia, I think is what they're trying to say.
But I guess my question is, why isn't every language on that list? Because with any language that has a C++ binding, you could run the code really fast, because you wouldn't actually be running, I don't know, Java code. You'd be running C++ just called from Java. You know what I mean?
No, but that's not... I mean, I guess it is the difference between libraries, calling a library, and your actual code. So sure, if you wrote one big library that was do really complex math for my problem in its totality, and all I did was write a Java program that said, call library, do my gigantic program. Yes, you could do that. Sure.
Well, I guess maybe another way of saying it is, why isn't MATLAB on this list?
Because nobody, that's what I'm saying, because nobody describes the computations in MATLAB for supercomputers that run at that scale, or hasn't, according to this thing.
Oh, I see. Because it's so big that it's really a distributed
That's
problem.
Right. So
there's no single machine that has 1.5.
So it's a whole bunch of things, right?
And so MATLAB has no or at least not built-in TCP
right. If you wanted to do it in Java, you're going to have to again, if you're not going to do it in a sort of hacky cheat way, you would need Java to handle all of the networking communication back and forth. You would have to have it doing the computation. Sure, at the lowest level, you say transpose this matrix. Maybe it runs machine code that originally came from C++. But I mean, so does everything else, right?
Right, I guess, but the reason why they're not all on this list is because of the distributed part.
Well, because of the distributed part and the complexity of the calculations and and the suitability for it.
Yeah, like presumably, let's say you want to invert a huge matrix, right? So to invert a huge matrix, it's kind of complicated. Like you have to give entire rows and entire columns to certain machines of the matrix. And it could be that doing that is so slow when it's Java calling into C++ or whatever that just doesn't work. And you can only really do that in Julia or by writing the whole thing in pure C. Because you have to take, a row of a matrix and mem copy it into a TCP buffer. And that's just not possible in Java, right?
Yeah, that's right.
So yeah, that makes sense. So basically, if you want to do distributed high performance computing, and it's not embarrassingly parallel, because if it's if you need to invert 10 million small matrices or a billion small matrices, you could achieve 1.5 petaflops. Like you would just give a small matrix to each machine, and you just do this with as many machines as you need to get 1.5 petaflops. But the issue is if you need to invert one huge matrix, and it's going to take 1.5 petaflops to do that, and all the data is kind of dependent on each other in weird ways, then you're pretty much either writing Julia or you're writing low-level C.
Yeah, and I guess the thing is, too, these machines, the computers, we could look at the supercomputer list. The supercomputers are very expensive to build, and so you're not going to just run, haha, cheeky, I want to get Java on the list. I guess they could. If someone cared enough to do it, they probably could write for any language, right? But the point is, these are typically used for real processing that makes money or government is paying for or research or something because, they need to be doing that. And so
makes sense.
To spend the time and effort to develop for these highly customized systems, you would want to know that you were going to get value out of it.
Yeah, totally.
So I'm looking, it looks like there are 305 in the whole entire world systems that run at a petaflop.
You mean clusters or just?
Yeah, clusters.
Oh, okay.
So,
wow.
Wait, you think that's high or low?
No, I think, I think that sounds reasonable.
So it is again, just 27, the 305th highest ranked. So I went to the top supercomputer ranking list. And I guess these are ones that are disclosed, right? So something like some Uber data center, not Uber, maybe Twitter data center or whatever, maybe has some, and it's not disclosed. And it's not really set up for this
I don't
either.
think, I was going to say, I don't think those count. Like you could say AWS is the most powerful cluster in the world. And technically, yes, except it's not like a coordinated cluster. Right. So it doesn't really
the
count. 300,
so I just scrolled down the sorted list until I found the last one that is still above 1,000 teraflops. And that is the 305th one. And that one has 27,608 cores.
Wow.
So it takes 27,608 2.4 gigahertz Xeon cores to get that performance.
27,000. 27,000.
Now, in theory, because these are only 2.4 gigahertz Xeons, in theory, you could probably have less cores. So here's one. So there are some on here with newer hardware that have only like 17,000 cores. Here's one with 15,000 cores.
If each board has 64 cores...
I don't have my calculator up.
Yeah, well, let's just say each board has 100 cores. That's still a lot of machines, right? That's 1,700 machines.
Yes. If I'm reading this list right, yeah. Some of these have 100,000 cores, yes.
Wow, that's wild.
But the lowest one I saw was sort of like 15,000 cores to get a petaflop.
Yeah, so Julia works at... Yeah.
We're off on a tangent now.
Yeah. But yeah, it's cool. It's compiled, which nowadays I think most things are compiled. Like even MATLAB I think it compiles it the first time you run it. Like Python, has the PYC files, but they're still going to be pretty slow. But Julia, it must compile down pretty quickly. You can tell they spent a lot of time on making it really fast. Yeah, and so I think it sounds pretty cool. I'll definitely try it out. Start using it for something and see how it goes. I'll report back.
All right. Till next time.
Cool. Have a good one.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.